So in this video, let's solve these problems now. See the fourth one, guys, it's very similar to what we have done in the in the previous video, okay, the problems part. See here, 1 by 2, 1 by 4, 1 by 8 till 1 by 2 to the power of n, correct? So in the first step, what do we do? So first step, let p of n is equal to 1 minus 1 by 2 power n, correct? Then let p of 1, so p of 1 will be equal to what? So p of 1 will be 1 minus 1 by 2, which is nothing but 1 by 2, which is the first part or the first term you can say. So you can say that p of 1 is true, correct? Now we'll do the next step. Let p of k be also true, and p of k is given by what? 1 minus 1 by 2 to the power of k, correct? So let's start with the third part now, third step now. So next, what do we have in the third step? We can say that p of k plus 1 will be equal to 1 minus 1 by 2 to the power of k plus 1. Isn't it? This is what we have. So we need to prove it now, right? Isn't it? So for this, p of k, that is 1 by 2 plus 1 by 4, so on and so forth till 1 by 2 power k. This is equal to 1 minus 1 by 2 to the power of k, correct? See, what are we doing? We are adding 1 by 2 power k plus 1, correct? So k becomes k plus 1. This is what we are trying to do now. Let's try to calculate this one now. The next part, the math part, we'll do it now. Now, what do we get? So we are going to get 1 minus 1 by 2 power k plus 1 by 2 power k plus 1, correct? Now, what you need to take is you need to take this much only in the sense for now, for simplification. So we'll get 1 minus 1 by 2 power k. See, remember, plus 1 by 2 power k into 2 power 1. Now what you do, take 1 minus 1 by 2 power k into 1 minus 1 by 2. Remember, we are taking minus 1 by 2 power k as common. Okay. So you got this. Then after that, what can you say? 1 minus 1 by 2 power k into 1 by 2. Isn't it? This is going to become 1 minus 1 by 2 power k into 2 power 1, which is nothing but 1 minus 1 by 2 to the power of k plus 1. This is nothing but p of k plus 1, what we had done in third step, right? Conclusion will write now. What you get is that p of k plus 1 by 2 to the power of k plus 1 is equal to p of k plus 1. So this implies p of k plus 1 is true. If p of k plus 1 is true, you can say therefore p of n is true. P of n is true. Clear? So this is the answer for the fourth one. Similarly, we'll do the next one. See the fifth one. A plus AR square till AR power n minus 1. Correct? Guys, start like the same thing. Alright, so in the first step, what do we write? So let P of n is equal to A into R power n minus 1 by R minus 1. Let P of 1 A into R power 1 minus 1 by R minus 1. R minus 1 cancels. So you're going to get A. That's basically the first term, right? So you can say P of 1 is true. Now in the second step, what do we write? Let P of k be also true. That means P of k is equal to a into r to the power of k minus 1 divided by r minus 1. This is the formula what we have, correct? Third step, p of k plus 1. We need to prove it, isn't it? So the third step now, what we have in this one is going to become, see, k plus 1, isn't it? So we are going to have a, or you can say first p of k plus 1, a into r to the power of k plus 1 minus 1 divided by r minus 1, right? So when we have to prove it, what do? We have a plus ar square till ar to the power of k minus 1, correct? This is equal to a into r power k minus 1 by r minus 1. So what do we add now? So plus, see here, a into r to the power of k plus 1 minus 1, isn't it? In place of k, you put k plus 1. So k plus 1 minus 1. So minus 1 cancels. Sorry, minus 1 plus 1 cancels. You will get this as a r to the power of k. So we add this to the RHS and prove p of k plus 1. Okay, let's do the math. You are going to have a into r to the power of k minus 1 divided by r minus 1 plus ar to the power of k, correct? Take the LCM. Very simple, take LCM. After that, we can take the a common. Okay, it's one and the same anyway. So a into r power k minus 1 plus a into r power k into r minus 1 whole divided by r minus 1. Make sense? Now, first you can take a common. Alright, so if you take a common, a into r power k minus 1 plus, see here, we can multiply this r power k and r, correct? So when you multiply, what are you going to get? R to the power of k plus 1 minus r to the power of k divided by r minus 1. Make sense what we just did? You are multiplying this r to the power of k with r and r to the power of k with minus 1. So you are going to get this. What gets cancelled? R power k gets cancelled. What do you end up with? A into r power k plus 1 minus 1 by r minus 1. This is p of k plus 1, correct? So let's write down the conclusion now. Right? We can say that p of k plus a r to the power of k is equal to p of k plus 1, right? So this implies p of k plus 1 is true. P of k plus 1 is true. Therefore, p of n is true. So this becomes the proof for the fifth question. Fair enough? Now let's do the sixth one. Sixth one, see, you are going to have, guys, it's the same logic. First two steps, three steps are one and the same. Okay, no difference. So in the first step, you'll have let p of n be equal to n into 4n square plus 6n minus 1 whole over 3. Then p of 1 is equal to 1 into 4 plus 6 minus 1 divided by 3. So if you look at this, 10 minus 1 is 9. 9 by 3 is 3. So you're going to get 1 into 3. So we can say that p of 1 is true. Correct? First step is this, very simple. Second step, let p of k be also true. Correct? And p of k will be k into 4k square plus 6k minus 1 divided by 3. Correct? This is what is p of k. Now we have to do P of k plus 1. So P of k plus 1. So this will be equal to k plus 1 into 4 into k plus 1 whole square plus 6 into k plus 1 minus 1 whole divided by 3. Quite a big one actually speaking, isn't it? This is P of k plus 1. Now we need to prove that P of k plus 1 is true. Correct? So when you're doing that, remember you have to do P of k plus the next term. Alright, so let's start with this. We have 1 into 3 plus 5, 3 into 5 till 2k minus 1 into 2k plus 1. Correct? Now what are we doing? In place of k and in place of k, we are substituting k plus 1, isn't it? So you will have 2 into k plus 1 minus 1 into 2 into k plus 1 plus 1, isn't it? Multiply 2k plus 2 minus 1, sorry, plus 2 minus 1 into 2k plus 2 plus 1. This is going to be 2k plus 1 into 2k plus 3. So 2k plus 1 into 2k plus 3. This is going to be the next term. Correct? So we'll look into this for the RHS part now. Alright? So you're going to have k into 4k square plus 6k minus 1 by 3 plus 2k plus 1 into 2k plus 3. Correct? So first, what can we do here? You can first take the 3 that side taking the LCM. Then if you want, we can try to split the middle term, but I don't think so. Splitting the middle term is going to help here. All right. I don't see that you can use the quadratic formula if you want, but let's not complicate things so much. All right. So what do we do here? K into 4k square plus 6k minus 1 plus 3 into 2k plus 1 into 2k plus 3 whole over 3. Correct? See here you can actually take up the product and you can try to add them. That will also work. Okay? See here what you can do. So you can take 4k cube plus 6k square minus k, correct? Plus 3 into 4k square plus 6k plus 2k plus 3 whole divided by 3. Multiply. You are going to have 4k cube 6k square minus k 12k square. See, 6 plus 2 is 8. 8 into 3 is 24. K plus 9 whole over 3. Isn't it? Group them. See, if you group, you'll get 4k cube plus 18k square. Sorry, 18k square plus 23k plus 9 divided by 3. Correct? Now what you can do is you have to do, see, either you can do the long division method by taking one of the cases, or you can try to take common here. Okay, so when you're trying to take common, what we can do is if you take the variables, then what we will get is we are going to get k plus 1 as common. So k plus 1 into you will have 4 into k plus 1 whole square, 6 into k plus 1 minus 1 divided by 3, which is nothing but p of k plus 1. So the conclusion, p of k plus 1 is true. Therefore, p of n is true. So this is the answer for the sixth one.